So my final question is to Mr. Ray, who has traveled from Kolkata for this session. And sir, I would like you to talk about the quantum arc furnace, which you have set up in GPH Bangladesh, if I'm not wrong. So please explain the technology, how it is performing in terms of the unit consumption and other efficiencies that it is achieving.
Okay, first of all, thank you for asking this question. So this has been our flagship product for the last few years. So we will start by telling you that at Prime Metals, we have been building electric arc furnaces for, let's say, 50 years or more. And the main, parameter of judging the performance of an electric arc furnace is how much energy it consumes in terms of, let's say, kilowatt hours per ton or units per ton. And a good performing electric arc furnace running on a scrap charge mix should consume around about 400 kilowatt hours per ton. Additionally, it produces a lot of hot gases which comes out of the furnace, and it also carries a lot of energy out with it. So many years ago, we put our efforts to find out how we can increase the efficiency of the system by utilizing the energy which is coming out of these hot gases. And we tried to use this energy to preheat the scrap so that the effective electrical energy consumption would be reduced. So theoretically, we put a benchmark of 300 kilowatt hours per ton. That should be the benchmark electrical energy figure. And then we designed this whole system, took care of the challenges in handling a preheated scrap, as well as what happens because sometimes these scraps also carry some organic compounds with them, like oils and etc. What happens if we preheat these oils in the scrap? So how we can take care of that? So these are the certain challenges that we encountered in the development process. And back in 2012, we commissioned our first quantum electric arc furnace in Mexico. Okay. And this was a 100-ton quantum arc furnace, and the results that this furnace yielded was that we could hit the 300 kilowatt hours per ton electric energy consumption. So then we started marketing this product, and so far we have built and commissioned 17 such furnaces. And like the one you're talking about is in GPH Bangladesh. It's about 80-ton tap size. And we are regularly operating in the range of 300 to 320 kilowatt hours per ton. And the variation of this power consumption happens due to the type of scrap that we are getting. Sometimes the scrap is not quite sorted or not quite prepared. So we'd like to stress that in plants in China, where we have around 12 of our references, we have seen that if the scrap is well prepared, and we can even go to 280 kilowatt hours per ton. So we think that as far as scrap recycling is concerned and low carbon footprint is concerned, quantum electric arc furnace is definitely the technology that is going to stay in the market for a long time.
Thank you. So one of the challenges that we as induction furnace manufacturing route, we feel that when we go to an electric arc furnace, the yield losses are comparatively higher in this technology. So do you think this power, that low power technology can compensate for the yield losses?
Well, compared to an induction furnace, definitely electric arc furnace has a slightly lower yield. But with a quantum furnace, we can improve the yield. And the reason behind that is pretty simple. First of all, since we are working on a preheated scrap, we are working on a flat bath. So this improves the yield to a certain percentage. And the gases which are coming out of this furnace, they sometimes carry a lot of dust. These are iron-bearing dust, and if we allow this dust to easily escape, then iron-bearing material is lost. This also reduces the yield. So with this scrap preheating technology, we have found that since we are filtering out the gas, So this iron bearing material is not escaping out of the furnace like it used to do in a conventional furnace. And we have experienced that about 1% improvement in yield is observed. So again, we have set ourselves a benchmark that if the scrap is well prepared, then the yield should be around 93%, if not more. So that is the benchmark we're working towards. And in our existing plants, we have already recorded brief periods of time where we could exceed this yield. And now we are trying to fine tune this technology to make this yield applicable on a regular and a reliable basis.
That is really exciting to hear and something that our industry would look forward to, sir. Okay.
Thank you. We will be very delighted to have a good response in the Indian market. And we are also customizing our solutions to low heat sizes. So specifically for the Indian market, we are strategizing heat sizes like 40, 50, 60 tons. So we are hopeful to get a good reception in the Indian market also.
I'm sure there'll be opportunities for collaboration.